Alright, we will be finishing the Objective 3 assessment packet by looking at numbers 6 through 10. Number 6 says, which graph best represents the function y equals negative 1.75x plus 5? Well, we'll consider the two parameters that we have. We know that slope is the coefficient of x. So in this case, that's the slope, negative 1.75. Slope. Point plus 5, this amount is the y-intercept. So instantly we know where the line is to cross the y-axis. It's going to cross at 5. That is the point 0, comma 5. Well, let's do a little process of elimination, crossing off all the graphs that don't have a y-intercept of 0, 5. Well, F does cross at 0, 5. That's a possibility. H, here's my y-axis, here's the line. There is the y-intercept, 0, 5, also a possibility. G, however, crosses below the origin. That y-intercept is 0, negative 5. So, G, not possible. Now J, 1, 2, 3, 4, 5. Indeed, J crosses at 0, 5 as well. So we've eliminated this one based on an incorrect y-intercept of 0, negative 5. Now we need a slope of negative 1.75. Well, one thing we know about slope is it will indicate to us whether the line is moving up or down. In this case, since the slope is negative, slope negative implies line moves downward. Since the slope is negative, we know that the line moves downward. So of the three we have remaining, F, H, and J, only one shows the line moving down. You can see F, the line's moving up. If I wrote my name on the line, it's moving up. This is positive slope. Positive slope. H also. We see the lines moving up. Positive slope. Moving up as we read from left to right. However, J, the line's moving down. We see line J, the line's moving down from left to right as we read. That is negative slope. J has a negative slope and a y-intercept of 0, 5. Number 6, the correct answer is J. All right, problem number 7. It says, which of the following best represents a linear function with a rate of change of negative 4/5? Well, we need to know that rate of change is slope. Rate of change is slope. So, in this case, we simply need to calculate the slope for each of these tables. In order to find the slope, we need 2 points. Need 2 points. And then we can employ the slope formula. M equals y2 minus y1 over x2 minus x1. You could refer to problem number 2 that we did. And this, pardon me, problem number 3 from the previous video will show how we can calculate the slope. So you can pick any 2 points off of these tables, find the slope, look for the 1, that has a slope that's equal to -4/5. Again, employing the slope formula, m equals y2 minus y1 over x2 minus x1. See number 3 from previous video. All right. Next is number 8. Get to the question sentence. What is the constant of variation? Well, this is a term that you may not be familiar with, but it's a synonym for slope. The constant of variation comes from our direct variation equation. Direct variation. Direct variation equation is one of the form y equals kx. And you can see this equation is analogous to our y equals mx plus b. Y is exactly the same, x is exactly the same. Here they're using k where we used m previously. In their case, they have no y-intercept. You can consider it being 0. In our case, b can be 0 and any other constant. So, in this form, y equals kx, this k is called the constant of variation. Okay? And the constant of variation is the slope. So again, on number 8, we will be finding the slope. To find the slope, we will use the slope formula. Again, referring to problem number 3 if you have any questions. All right. Problem number 9. Again, first I get to the question sentence. Which employee drove at the slowest rate to the convention? Once more, rate is a reference to slope. And one context we have for slope is steepness of a line. So in this case, to determine who has the greatest rate, you would look for which line is the steepest. That is problem number 9. Lastly, number 10. The question says, what are the x and y intercepts of the graph of this linear function? Well, the x and y intercepts are the point where the graph crosses over the x and y axis. Reminder, if we have a graph that graph will intersect both the x and y axis, usually. The point where it crosses over the y-axis, in this case that might be 0, 3. 1, 2, 3. 0, 3. This is called the y-intercept. The point where the graph crosses over the x-axis, in this case may be 1, 2, 3, 4. This point is -4, 0. This is the x-intercept. Notice at the x-intercept, x is the non-zero, but y is the 0. We didn't move up or down any. At the y-intercept, the y is the non-zero, but x is the 0. At the y-intercept, we didn't move left or right any. Consider what we've done here. Graph these points, draw a line through it, and determine where the line crosses both the y and the x-axis.